Well, we're going to talk about sketching some graphs of inverse trig functions, and we start off here with y equals the inverse sine of 3x. And that's actually what I have graphed right here. I just simply graphed the inverse sine of 3x. And let's talk about how I did that with the table of values. If I want to do that with the table of values, I might think about that. What's the inverse of the arc sine? Well, it's just the sine. So I could then say the sine of y is equal to 3x. And then if I'm going to isolate the x, what are the x values? Well, they're 1/3 the sine of y. And remember, when we're talking about sine functions, we're talking about the right half of the unit circle. So in my table of values, if I set y equal, ranging from pi over 2 to negative pi over 2, which is what I've got right here, and then those special angles in between, we can determine what the x value is if x is equal to 1/3 the sine of y. So when y is pi over 2, what's the sine at pi over 2? It's 1. 1/3 times that is 1/3. And what about at pi over 3? We're coming down, moving from pi over 2. We're going clockwise here. Pi over 3, well, the sine at pi over 3 is the square root of 3 over 2. 1/3 times that's going to be the square root of 3 over 6. And at pi over 4, well, the sine at pi over 4 is the square root of 2 over 2. 1/3 times that is square root of 2 over 6. Which is what we have right here. And when at pi over 6, well, the sine at pi over 6 is 1/2, and 1/3 times 1/2 is 1/6. And what about there at 0? Well, the sine at 0, the value of y at 0 is just 0. Well, 1/3 times 0 is 0. And then as we continue moving towards negative pi over 2, well, when y is negative pi over 6, the sine is going to be negative 1/6. At negative pi over 4, our x is going to equal negative square root of 2 over 6. When y is negative pi over 3, we got negative square root of 3 over 6, and at negative pi over 2, we got negative 1/3. And so what we see here in our graph is we're actually going to have a closed dot here at negative pi over 2, and y equals negative 1/3. Let's see, I set my scale up to be negative 1 and 1 on the x-axis with a scale of 1/3, and on the y-axis I was pi over 2. Negative pi over 2 with a scale of pi over 4. So I can see that. I'm going to have a closed dot here up here at the top at pi over 2. So when x is at 1/3, y is pi over 2. And when x is at 0, y is at 0 as well. So the graph is just simply graphing the inverse function, but here we built a table of values and we can track that. Let's see, pi over 3, we'd be up here somewhere. Pi over 3 is greater than pi over 4. And we said that would be the square root of 3 divided by 6. What is the square root of 3 divided by 6? Let's see, square root of 3 divided by 6. It's 0.28. Square root of 2 over 6, which is what we would be at pi over 4. So square root of 2 divided by 6 is 0.235. So we're moving down this way, right, until we get to 0. And then we're continuing here out this way until we get to when y is negative pi over 2. The value of x at that point is negative 1/3. Okay, let's look at a tangent function next. And it's a similar thing, except we're going horizontal asymptotes. So here I built this scale. Let's see, how did I do this? I think, well, I know I kept this at pi over 2, negative pi over 2. I used the scale of pi over 4. And you can see we're going to have horizontal asymptotes at pi over 2 and negative pi over 2. And why is that? Well, remember, tangent is equal to the sine over the cosine. And if I rebuild this for values of the inverse of the inverse tangent is the tangent of y now equals 2x. Therefore, x is going to equal 1/2 the tangent of y. Well, at pi over 2, the sine is 1, but the cosine is 0, and so we would be undefined. And at pi over 3, let's see, we've got to the sine is going to be the square root of 3 over 2. The cosine is going to be 1/2. So the square root of 3 over 2 times 2, the reciprocal of 1/2, is going to give us the square root of 3, but we got 1/2 of that amount. So that gives us 1/2 square root of 3. At pi over 4, well, the sine is square root of 2 over 2, and the cosine is square root of 2 over 2. That equals 1. So 1/2 of that is 1/2. At pi over 6, the sine is 1/2, and the cosine is the square root of 3 over 2. So 1/2, let's say 1/2 times is 2 over the square root of 3. Those are going to cancel. Give us 1 over the square root of 3, but we rationalize that denominator. It's going to give us the square root of 3 over 3. But when I apply 1/2 to that, now I've got 1/2 times square root of 3 over 3, or I could say it's the square root of 3 over 6. And at 0, what's happening at 0? Well, the sine is 0, but the cosine is 1, so that's just 0. And then again, all the way out here at the left hand, or the right of my table at negative pi over 2, again, the sine is negative 1, but the cosine is 0, and so therefore it is undefined. And so while our domain can go from negative infinity out to infinity, as many times as this were to cycle, I got horizontal asymptotes of pi over 2 and negative pi over 2. Okay, we may need to talk about this a little bit more. It gets a little bit confusing. I got confused here a little bit myself.